In this video, we are going to be looking at the graphs of trigonometric functions at GCSE level. We're going to look at sine and cosine. We're going to solve equations using the graph, and then at the end I'll introduce the tan function as well. The sine graph and the cosine graph are almost identical. Sine starts at 0, goes through 0 at 180 and 0 at 360, and it follows a wave-like pattern where it starts going up. It crosses through 90 and 1 and 270 and minus 1. Sine x looks like this. It is a smooth curve that looks like that. This is y equals sine x. Cosine x is almost identical, but it's just shifted by 90 degrees that way. We move the graph 90 degrees this way. So it starts at 1 and comes down to minus 1 at 180 degrees, 270 degrees is 0, 360 is 1. And again, it is not, now this one especially is not a V. Okay, if you look here, this graph is a smooth curve, and this one has to be as well. So it's a smooth curve that looks something like that. This would be the graph y equals cos x. Now you don't need to understand why this is the case, you just need to remember it. And the easiest way to do it, that I think, is just sine starts at 0. Just remember that, sine starts at 0 and then everything else follows. Okay, just follow my explanation through. It's a smooth curve, it rises and falls, or it falls and then rises. Okay? Now we need to be able to use these graphs to solve equations. Let's start with, for example, 3 sine x equals 1. I can first off rearrange, I can first off divide. So I need to find sine x, which is 1/3. Sine x being a third would come through at about here somewhere, there's a third. So I'm going to go, like I would do with any normal graph, I'm going to go along and go down. Come along to here and go down. So in my calculator, I'll put in sine inverse of 1/3. Okay, sine inverse of a third, just put it in, so shift sine 1/3, close your brackets. You get x is 19.5 degrees to 3 sig figs. Okay, make sure, if you don't get that, make sure at the top there's a little d there. Okay, if it says R, it means your calculator's set up wrong. You need to put it into degrees. But that is not the only answer. In your exam, it will probably have x equals ... or ... It will have 2 sets of answers. The other answer comes from as we move along. If we carry on through, you should see you get another answer. Now what you have to do is use the symmetry of the graph. This value here is the same as this value here, up to 180. So this is 19.5 and therefore this is 19.5 as well. The other answer is 180 minus 19.5, which is 160.5 degrees. If you put that in your calculator, you will get a third. Oops. Well, almost a third anyway. Okay, you'll almost get a third. It won't be exact because you haven't quite rounded it. Because we rounded it here. Let's do the same, but now with cos x. Let's say that 2 cos x equals minus 1. So if I plot that, well actually first off we need to rearrange it. So cos x is minus 1/2. If I put that on the graph, that's here, that's minus 1/2, and then come up, and then I do it again here, I will get 2 answers. So let's do cos inverse of minus 1/2. If I put that in my calculator, x is cos inverse minus 1/2, I get 120 degrees as one of my answers. So this value here is 120 degrees. You now can use the symmetry of the graph again. You can either know that from there to there is 120, So I can do 360 minus that. Basically, these distances here and there are the same. That's one way of doing it. The other way of doing it is seeing that that is 30 degrees, and therefore that should be 30 degrees as well. Whatever you do, whichever way you want to do it, 360 minus 120, or 270 minus 30, you get the same thing. You get 240 degrees. And that would be how you would solve a relatively complicated graph. You have two answers. Now, very quickly, I'm just going to draw the graph of tan. So, tan x looks like this. And there's 90, 180, 270, and 360. Tan starts at 0 again. But there are asymptotes. An asymptote is where the line of the graph never crosses. There's an asymptote at 90 degrees and an asymptote at 270 degrees. The graph comes up like that, passes through 180 at 0, comes back up, jumps back down again, and then comes back at 360. The line does carry on. So just like this one here with the cos, kind of carries on and it goes down and up and down and up and down. Same thing with the tan. The tan graph carries on up there and does carry on down there as well. But you don't necessarily need it. You probably won't be expected to solve it, but let's say you wanted to solve tan x equals 1/2. I'd go tan inverse 0.5 to get my answer. X is 26.6 degrees, again to 3 sig figs. So that is here. If this is 1/2, that value's there. But I also have one more value. My other value is here. So this is 26.5. And also, if you think about the symmetry of the graph, it crosses through at 0 and crosses through at 180. So all I need to do, that would also be 26.5. So the other answer is 180 plus 26.5, which is 206.5 degrees. Turns out with tan, all you need to do is add 180 to your answer. So even if your answer's down here at 110, just add 180 to it and that will give you the other answer. And that's a very brief overview of how we would use the graphs of trig functions to solve some simple trig equations.